We're talking factors and multiples today, and we're going to figure out how to use greatest common factor and least common multiple in real life situations. Today's lesson is all about factors and multiples, so we're going to do a real quick elementary review, and we're going to use a little saying to help us remember. Here are a few factors and many multiples, and we're going to use this with the number 12 and think about it in both ways. We know factors are numbers that we multiply to make 12. So when I think of my factor pairs, I know that there's 1 times 12, 2 times 6, 3 times 4, and that's it. You also notice that I tend to start from the biggest pair, 1 and 12, and my numbers tend to then go in order, and I know I'm done when I get to the end. So it always kind of loops together. But that's just a little trick that I've used since I was younger to help me know when to stop with my factors. So there you have it. There are exactly 6 factors for 12. 1, 2, 3, 4, 6, and 12. That's it. These are the only ways you can evenly share 12. Only in those sets of numbers in those groups. But there are many multiples, and they go on forever. So thinking again also of the number 12, I can do 12, 24, 36, 48, 60, 72, and I can keep going on and on and on and on forever and ever and ever. I can continue to skip counting by 12s and make more and more multiples. So this is just a big difference. Factors are how we break a number apart. So kind of like if you have a glass, like let's say there's your glass and you fracture it, you break it, you cut it up into pieces. That's what factors are. Factors are the pieces, the even groups of pieces that make 12. But multiples go on and on forever, like copies. I can keep on skip counting by 12s forever and ever and ever. So as you're working through a problem, try and think, am I working on making groups? Like, are my groups breaking the number apart? Or am I using groups to make more of the number? Let's jump into our first model. We're going to have 2 problems today for the model, one with multiples and one with factors. Let's see if we can tell which is which. Jackson wants to buy the same number of stamps and envelopes. Stamps are sold in packs of 6 and envelopes in packs of 4. What is the least number of stamps and envelopes Jackson will buy? So this is pretty easy. What are they asking us? What's the least amount of stamps and envelopes he has to buy? And that's like if you go into Costco, you know how you have everything in bulk, but things come in different numbers. It's kind of like that, where he has to pick up packs of both, but he wants to make sure he has the same number of both. So what are our facts? We know stamps come in packs of 6, envelopes in packs of 4, and we want to buy the same number of both. So here's my plan. Since I'm starting with 6 and 4, it's not like I'm taking one pack and breaking it into pieces. So I don't want fewer than 6 and 4. I'm going to have more than 6 and 4. So many multiples. So I'm going to list the multiples of 6 and 4. And I'm going to look for a common multiple of 6 and 4. Otherwise known as the least common multiple. Let's see it in action. So we're going to make our list of 4s and 6s. And it's funny because in my mind I almost thought of it like I'm just buying packs of 4, like when I go to the store, and I'm just buying packs of 6, and I just want to make sure when do I stop so that they're both at the same number. That's exactly what we're doing here, but we're going to use the list so we can see the numbers. So we'll start with 4s. 4, 8, 12, 16, 20, 24. I'm just doing about 6 numbers to start because remember, multiples can go on forever. And let's do the same thing with 6, 12, 18, 24, 30, 36. Let's stop and take a look-see. Let's look what we got. Do they have anything in common? My eyes just moving around. Do you see it, Math Marbles? Do you see it? I see some things that they have in common. So for example, I see they both have a 12 and they both have a 24. And I'm pretty sure, as a matter of fact, I am certain if we kept on going, we would find more numbers they have in common. But that's not our goal. We don't want just any number. We want the least amount because we don't want to keep buying extra. So our least common multiple in this case is 12. I'm picking 12 because it's smaller than 24 and that is what we want. So I'm going to write this down as a complete thought and sentence. The question was, what is the least number of stamps and envelopes Jackson will buy? So let's restate that. The least amount of stamps and envelopes Jackson will buy is 12. Now I'm even going to put a comma. That means 3 packs of envelopes and 2 packs of stamps. That is a beautiful response, Math Marvel. Yep, I know I went extra on that one. But there you have it. This is how we can demonstrate finding the least common multiple. Big takeaway, just make sure as you're listing, you're looking for the smallest number, not just the greatest. Hit pause and jot this down into your notes. Let's read the second problem together. I'll read aloud while you read in your head. Alicia is putting cheese cubes and crackers on small plates. She has 40 cubes of cheese and 40 crackers. She wants both cheese and crackers on each plate, and each plate must have the same number of cheese cubes and the same number of crackers. What is the greatest number of plates she can make using all the cheese and all the crackers? So that's our big question. Just at the end, we want the greatest number of plates using all the cheese and crackers. So we're starting with total and we're just distributing it out. So we're sharing. It's making me think already the difference between factors and multiples. We know she has 24 cubes of cheese and 40 crackers. And we want each plate to look the same so that every plate has the same number of crackers and cheese. So I want to just make sure that's clear. If there are 5 crackers on one plate, there are 5 crackers on another. If there are 5 crackers and 2 pieces of cheese on one plate, there are 5 crackers and 2 pieces of cheese on another plate. So here's my plan. Since I know that we're starting off with all the crackers and cheese we have, we're going to list all the ways to evenly share the crackers and cheese by listing the factors of 24 and 40. Take 30 seconds to jot this down in your notes. And now let's see the plan in action. So we're going to start by listing. Remember, I'm starting with this as a total. So my number should be less. I'm not going to have more than 24 or 40 on every single plate. And the trick to this is we want factors. So I'm going to list using my factor rainbow and starting with my biggest number first. And I'm thinking about ways to evenly share for both. So give yourself space and room. I'm going to go with 1 and 24 first, since they are a factor pair, followed by 2 and 12. Make 24. Is 3 a factor? Yes. 3 times 8. And 4 times 6. 905 is not a factor. So this is just using a factor rainbow. I can see all my factors. And I'm thinking consciously about, can I divide by that number? We'll do the same with 40. 1 and 40. It's an even number, so I can use 2. 2 and 20. 3 does not work. 4 does work. 4 and 10 are factors. 5 and 8 are factors. So look at how my rainbow's getting smaller and smaller. That leaves only the number 6 and 7. And knowing my times table, 6 and 7 are not factors of 40. So now's our time to go and look and take a look at our numbers. What factors do they have in common? I see they both have 1, 2, 4, and 8. And we are looking for the greatest common factor. So out of all those numbers in common, the greatest one is 8. So what does the 8 mean? Does that mean she has 8 pieces of cheese and 8 pieces of 8 crackers? No, it means these are the 8 plates. So let's put that into a full sentence. Alicia can create 8 plates. And I'll go a little further. Each plate will have, and now think, for the 24 cubes of cheese, if she has 8 plates and you're giving that out, how much will each plate have? They'll have 3. Or I can just use my factor rainbow to kind of help me with this by looking at this factor pair. Each plate will have 3 cubes of cheese and 5 crackers. And that makes sense because 3 times 8 gives us our 24 total pieces of cheese, and 5 times 8 will give us our 40 crackers. We have found the greatest common factor. Hit pause and jot this into your notes. Well, that's our lesson today. Few factors, many multiples is the biggest takeaway. Use your logic as you're reading through the problem. Am I starting with a total and I'm breaking it down into smaller groups because I'm sharing? Those are factors. Or am I making more and more? Am I buying multiple sets? Those would be multiples. See you in the next lesson.